Grade 10s, good morning. How are you guys doing today? Welcome to lesson number 5 in this series of video recordings. Today we're going to be looking at transition elements. In the previous lesson we looked at group 7 elements. We took 2 lessons to do that. We looked at halogens in 2 parts, and in the final one we looked at the displacement reactions and some other properties of those group 7 elements. Today I'm going to give basically a short lesson on transition elements. I know it's a brand new concept, but it's mostly theoretical, and I know you guys are very good with reading, right? You like reading and regurgitating material that you would have read. So this is mostly a lesson where you read, so I will just go through some of the points, and then you guys will just read by yourself. So what are our objectives for this lesson? By the end of this lesson, you must be able to identify transition elements on the periodic table. You must also be able to describe the common characteristics of the transition elements, right? These transition metals, please. Okay, so you should be able to describe the common characteristics of transition metals. And you should also be able to explain their uses, explain the uses of these transition elements. It's very simple stuff. It's very simple stuff. I hope you have the notes, and I hope you have read the notes already. I'm telling you, I'm going to brush through this because there is not much to it. It's a very simple concept. So take a few seconds, right? A few seconds, maybe half a minute, to just look at the objectives of the lesson, look at your PDF document, make sure that you have a periodic table with you. You must definitely be having a periodic table with you. Okay, so the first thing we will want to know in this lesson is to say, where exactly are these transition elements? Remember we said we looked at group 1 elements, and they were pretty easy to identify on the periodic table. You just look at your periodic table, and the first group we said was the group 1 elements, the second group was the group 2 elements. Then the transition elements or transition metals are also sometimes known as the D block elements. The D block elements, and you will find them between group 2 and group 3. Between group 2 and group 3, you will find that there is a big space, and there are a lot of elements that are there in the middle, right? That are there. Yeah, if you have group 1, group 2, then you have a lot of elements that are in the middle. Then those ones are known as the D block elements. They are known as the D block elements. Now, just to get the problem out of the way, the question will be, why exactly are they there? And why don't we say then the next column is group 3, then group 4, 5, 6, 7, 8, 9. These transition elements do not belong to any specific group because they have an unstable outer shell. What do we mean by this? Remember, the group number of an element or of an atom is determined by what? What determines which group number an atom is going to be found in? The group number of an atom is going to be determined by the number of electrons it has in its outer shell. Number of electrons in its outer shell. So for example, if we give the most common example, if we give sodium, right? If we say sodium, or if we think of magnesium, right? I remember that magnesium, sodium has this electron configuration of 2, 8, 1. 2, 8, 1, right? And that 2, 8, 1 implies that it has 1 electron in its outermost shell. This is the simplest configuration, right? This is the simplest configuration, 2, 8, 1. So this means that sodium has 1 electron in its outermost shell. And if it has 1 electron in its outermost shell, it means that it's going to be found in group 1. Magnesium has 2 electrons in its outermost shell, therefore it is in group 2, right? That's just some foundation material. The transition elements, however, if you go to their outermost shell, if you go onto the atom of iron, the iron atom of copper, zinc, all of these transition metals or transition elements, they do not have a fixed number of electrons in the outer shell. Sometimes you will find that there will be 2 electrons in the outermost shell. Sometimes that second electron will jump and go into a different shell. Now you are left with 1 electron in the outermost shell. So it differs. And because of that, that is why these D block elements cannot be found in specific group numbers to say this is in group 4, this is in group 5. Right? I hope we understand that part. So just take a minute or so just to digest that bit of material. Right, so if we are looking at these transition elements and we now know where they are found, and we're saying they are found between group 1, actually between group 2 and group 3. It is those elements that are there. Do not, please do not confuse them with the elements that are in the lanthanide series. Those ones that are at the bottom, these ones, just leave them alone for now. We are talking about the D block elements, the D block elements. So the ones that are between group 2, I'm holding 2 papers, that's why it's becoming a bit difficult. Between group 2, you see where there's beryllium, magnesium, calcium. Between beryllium, magnesium, calcium, and boron, aluminium, those elements that are there, those ones are the transition elements. Those ones are the transition elements. So if we then look at the properties of these transition elements, just hold on a bit. So if we look at the properties of these transition elements, they are transition metals, right? So let's try to refer to them most of the time as transition metals. This will help us how? This will help us understand their properties. If we look at their properties, we'll find that these transition metals have, if we look there, they have a high density, and below that there is high melting point and boiling point of above 1000 degrees Celsius. Right? So high melting points and high boiling points, high densities, these are characteristic of metallic substances. If you remember when we were in grade 9, we looked at metals. Right? So if you recall those properties of metals, say they are shiny, they are lustrous, they are sonorous, they apply also to the transition metals, because this is where those metals that we actually encounter in everyday life, like copper, iron, zinc, that's where those metals are found. We also have other metals there, of course, like scandium, and then you can't say you've bumped into osmium or what's it called? Iridium. Tungsten, we know it. Tungsten, we've seen it, is there in the bulbs, right? Iridium is there. We know it, or maybe you don't know it, but it's also common. But these are transition metals. And because they are metals, they are obviously going to have high densities, they are going to have high melting points, high boiling points, and the other characteristics which are common to metallic substances. They are usually, or not always, they are usually solid at room temperature, with the exception of mercury. Right? Mercury is the only transition element there that you'll find that is actually liquid at RTP, at room temperature and pressure. Right? So if they also conduct electricity, because we know, that's why I said we don't have to take that much time in this lesson. They conduct electricity, that's because they are metals, right? So because they are metals, we know that one of their properties has to be that they conduct electricity. But what I think is the most, they also form colored compounds, right? They form colored compounds. If you are looking at like your textbooks in living chemistry, you'll find that the manganese oxide, if you were to see manganese 4 oxide, you'll find that it's usually, if you say something like potassium permanganate, right? Those oxides, they're usually orange or purple, and they always have these nice radiant colors, right? And that is as a result of the absence of stable d orbitals, right? Electrons in the d orbital. We're not going to talk about d orbitals that much. I will explain it just a bit in the lesson, but it's not really necessary. But if we talk about electron configuration, we know that we talk about how we have 1s2, 2s2, 2p6, right? And the spd orbitals, those ones. And it is an absence or a lack of stability in that final d orbital. They all have d orbitals, these transition elements. And the absence of that stability in that d orbital is what results in the changing of colors. So if you were to see potassium manganate, the colors are so beautiful. I think we use them when we do titration reactions, right? When you do titration reactions, we use some of them, and they actually get to show us the presence or when equilibrium point has been reached. But that is for another day. So the other interesting concept that I wanted to point at was the issue of varying valences. We already said they're varying valences, which means that what is valency? Valence refers to the number of electrons that are in the outermost shell. So if you look at the valency of these transition elements, these d block elements, I hope you guys are looking at a periodic table. And I'm just going to break off a bit. I hope that you are giving yourself the time just to read this from different sources and to remind yourself that this is easy stuff, right? The moment you just give yourself a chance to understand it, it's easy to understand, right? So going back to varying valences, if you look at varying valences, the concept that is there is that if you have copper, right? We have something that's called copper 1, copper 2. It means that if you were to draw, you remember those Bohr diagrams that we say, let's draw 20 Bohr diagrams for the first 20 elements. And you're like, why were we drawing all these Bohr diagrams? That's why, because we wanted them to stick in your head. Now we have moved on past the first 20 elements, and we're looking at elements such as iron and copper. So when you're looking at this copper, okay, just take a bit of time. Let me give you a couple of minutes to go onto your periodic table to just go and look at some of the transition metals which you think you would be able to identify. Okay, just look at your periodic table, feel no pressure. Just take maybe a minute or two to just identify these transition metals. And if it's possible, you can try to draw their Bohr diagrams, if it's possible, if you can. Okay guys, I hope you had a chance to look at your periodic table and to see, apart from iron and copper, which are obviously on the board, other transition elements such as cobalt. Remember when you have cobalt, that cobalt is actually the one that has the symbol CO. Don't make the mistake of seeing the symbol CO and assuming that CO is for copper. CO is for cobalt, Cu is for copper, zinc, and other transition metals. Right. So when you see these ones which we're saying they're varying valences, right? If you were to go into the outermost shell of copper, you would find that it's not always going to have the same number of electrons in the outermost shell. That's what we mean by saying that the elements are unstable. These elements are volatile, they're unstable. You come one day, it's having 2 electrons in the outermost shell. You come the following day, you say, oh, you were having 2 electrons in the outermost shell yesterday. He says, no, you're not talking about me. I have only 1. That's because it is unstable. You have to understand what unstable is, what volatile is. I asked you guys to go and look for the meaning of the word volatility, or what volatile means, right? So these are volatile substances. Right? And because of that, they form different ions. Remember, let me give a quick example of an element like sodium, which I drew there. Sodium is in group 1. So it always forms ions with the charge Na+, just the charge +1, positive 1, because sodium is in group 1. However, copper sometimes will form copper plus, sometimes will form copper 2 plus. Right? So copper 1 is the copper that you would have found with 1 electron in its outermost shell. Copper 2 is also a variation of that same copper which you would have found on that particular situation or that particular moment actually having 2 electrons in its outermost shell. Same applies for iron 2 and iron 3. That sometimes you will find iron having 2 electrons in its outermost shell, or sometimes it will be having 3 electrons in its outermost shell. And this determines which ion it forms. Sometimes it will form iron 2, sometimes it will form iron 3. Right? So iron 2, the one that has 2 electrons in the outermost shell, will form iron 2 plus. Iron 3 forms Fe3 plus, iron 3 plus. That is the issue of the variance of the valency shells, right? The valency electrons, and that then informs you to say if you see all these compounds that they form, right? You will say you form copper 2 chloride, right? Copper 2 chloride, or copper 1 chloride, or copper 1 oxide, or just copper oxide, or copper 2 oxide, iron 3 oxide, iron 2 oxide. That is where it is coming from, to say the ion that was used for this reaction actually had 2 electrons only in its valency shell. The ion that was used for this reaction had 3 electrons in its valency shell. I'm not going to explain anything further. You guys will look at these, what are these called? These properties, right? Their uses. Okay, you can also just look at the uses. They are mostly used if you look at catalytic converters, right? Catalytic converters, those ones which are found in exhaust pipes of cars. Catalytic converters, right? Cars have catalytic converters which allow them to reduce the amount of harmful substances that they are letting out into the atmosphere. I hope you know about this, right? Or you can read about it. That's the good thing also. That so if cars are producing, they produce harmful substances, sulfurous oxides, right? But these sulfurous oxides again have to be converted into less harmful oxides, which can then be either absorbed into the atmosphere, or if you think of carbon monoxide, and then you change the carbon monoxide and it becomes carbon dioxide. Carbon monoxide is poisonous, it is harmful. Carbon dioxide goes into the trees, right? Use of what? Of these transition elements. Okay, so you can look at other uses, making dyes or whatever it is they are used for. I won't even go much into it, right? So you guys, this is Marshall AC Candido. You guys have been great. We have covered what we were supposed to cover. So I'll meet you tomorrow in the actual WhatsApp lesson. Okay, cool.